Within this video, we're gonna to speak about calculus and I will make a quick wrap up about the calculus and the branches that you will study within calculus about topics. Introduction about calculus. The lessons or the topics that you will study in the calculus here is definition of calculus, classification of calculus, differentiation, formulas of differentiation, examples of differentiation, integration, formulas of integration, example of integration. Classification of calculus, which means that there are two main types of calculus: differential calculus or integral calculus. We'll start with integral here, a branch of mathematics concerned with the theory and applications, as in the determination of length, areas, and volumes, and in the solution of differential equations, of integrals and integration. But what about the differential calculus, a branch of mathematics concerning with the study of the rate of change of functions with respect to their variables, especially through the use of derivative and differentials. Differentiation. What is differentiation? The process of finding a derivative is called differentiation. The reverse process is called anti-differentiation. The fundamental theorem of calculus states that anti-differentiation is the same as integration. Differentiation and integration constitute the two fundamental operations in single variable calculus. Here are all the rules that you will follow in differentiation, and I will speak about rule and I will give you example about this. Let's start. Differentiation formulas for basic functions. First one, the derivative of a constant function f(x) equals c. Constant number is any number without any variable, so the derivative of c is equals 0. D to dx or d over dx, which mean derivative. So here I will say derivative of c is 0. Any constant will be 0. So the derivative of any constant will be 0. Differentiation formulas for basic function. Number 2, the derivative of a constant function f(x) equals c. Do you remember what we said before? Yes, the constant will be 0, so the derivative c equals 0. What about number 2? The derivative of here, identify function f(x) equals x. Yes, it will be 1. It will be the coefficient of x. So the derivative of any function like x, it will be the coefficient of it, it will be 1. So if it's 2x, it will be what? 2. Okay, if it's negative 5x, it will be negative 5. You got this? So here I have two cases. First case, the constant, so the derivative of constant equals 0. And the second one is like a linear function or identity function like x or 2x or 3x or negative 4x or negative third x. It will be the coefficient of x. Moving to the next slide here. The power rule. Let n be any integer, okay, other than 0, and a be some constant, whatever. Then the derivative of the function will be, yes, do you see here? derivative of ax all power n, ax power n equals, yeah, I will bring down the power here. I will bring down the power n like this. Then I will write n times ax, and the power will be n minus 1. Repeat it again. I will bring down the power next to a, so it will be n multiplied by a x, and the power I will subtract 1 from it. You got it? Okay, what about the exponential rule? The exponential rules is like to take len, okay, the derivative of an exponential function with base a, fx equals a power x, so derivative of ax equals len a multiplied by a power x. These rules should be registered in your mind. I want these rules to be registered in your mind, please. So the rule, the derivative of the power or exponential function, it is to put len the base, len a multiplied by a power x2. Okay, here as we speak first about the exponential function with any base, any integer base. Okay, what about for number 2 here? If it will be fx equals e power x, yeah, it will be the same e power x. Okay, so again here the power rule, if it a power x, as a is a base, any number of a power x, so it will be len a multiplied by a power x. Okay, what about if it will be e power x? Yes, it will be the same, so the derivative of e power x equals e power x2. Okay, what about the constant multiple rule? What is this? If c is a constant and f is a differentiable function, what I will do, the derivative of c times fx equals, you will get c outside, then make the rule over derivative of fx, you will make the rule of it and just put the constant outside the derivative like this. We'll see by examples. Here, the addition and subtraction rule, if f and g are both differentiable functions, then I will solve each one alone, then add the answer together. Okay, so here the derivative of fx plus gx together, it will be derivative of fx plus derivative of gx, and so on. If the derivative of fx minus gx, so it will be equals derivative of fx alone minus derivative of gx.